Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic Faraday's laws of electrolysis. Now, first of all, let us see or go through some important points. Electrolysis is a technique that uses electric current to complete a non-spontaneous chemical reaction. And Faraday's laws of electrolysis describe the relationship between the amount of electricity passed through an electrolyte and chemical change that occurs. The amount of electricity that is needed to release 1 gram equivalent of a substance at an electrode is called a Faraday. Now first let us see what the first law states. The first law states that the amount of chemical reaction which occurs at any electrode during electrolysis is proportional to the quantity of current passing through the electrolyte. Now, first of all, let us see the relationship between charge and current. You see Q equal to IT, where Q is the charge and I is the current. Q is in coulombs, I will be in amperes and T in seconds. And M will be directly proportional to Q. Okay, M is directly proportional to Q, or we can say that M equal to Z into Q. For Z, the unit will be grams per coulomb. Now the second law states that the amounts of different substances liberated when the same quantity of current is passing through the electrolytic solution are proportional to their chemical equivalent weights. So W directly proportional to E, because the amounts of substances liberated are proportional to their chemical equivalent weights. The amount of current which is required for oxidation or reduction depends on the stoichiometry of the electrode reaction. Now see, in case of silver cation, Ag plus electron gives Ag. So 1 mole of electrons is required for the reduction of 1 mole of silver ions. We know charge on 1 electron is equal to 1.6021 into 10 to the power minus 19 coulombs. So, for 1 mole of electrons, it will be 6.02 into 10 to the power 23 into 1.6021 into 10 to the power minus 19. That is 6.02 into 10 to the power 23 into 1.6021 into 10 to the power minus 19. So we are multiplying the value for 1 mole into charge on 1 electron. So what we get is 96487 coulombs per mole. So this quantity of current is called as Faraday. 1 mole of magnesium ions will require 2 moles of electrons, as we can see in this equation. Mg2 plus we can see here. For magnesium, let us write the equation first. Mg. Yeah, Mg2 plus 2 electron gives Mg. So 1 mole of magnesium ions will require 2 moles of electrons. But for aluminium we see Al3 plus 3 electrons gives Al. So 1 mole of Al3 plus will require 3 moles of electrons. Now let us solve one numerical based on this concept. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at the cathode? T time 10 minutes, that is 10 into 6600 second. Charge is current into time. 1.5 ampere into 600 second is 900. So charge is 900 coulombs. Now the equation is Cu2 plus 2 electron gives Cu. Now here we require 2 into 96487 coulomb because we require 2 electrons. So here 2 into 96487 coulomb is needed because we know that 1 mole of electrons is equal to 96487 coulomb, that is per mole. So here 2 moles will be needed total. So it will be 2 into 96487 coulomb, and that will give 63 grams of copper. So if we are using 900 coulombs, the mass of copper which will be liberated will be 63 grams per mole into 900 coulomb by 2 into 96487, which is coulombs per mole. That is, for 1 mole it is 96487. For 2 it will be 2 into 96487. On calculation we get 0.2938 grams. 0.2938 grams. So I hope students you all could understand the topic which we discussed today, and I hope you also could understand the numerical which we solved. Thanks for watching my video. Please subscribe to the channel and share the video. Thanks for watching. Thank you all.